Yeah, that's a good point. It sounds
Okay,
like previous.
so today we're going to go over the safety and basic use of our 3D printers. We're not going to go over every little thing, but basically I want to kind of work through with you guys how to use the printers, some basic printing methodology and understanding of um, like why and what these printers do, and then the flow from the beginning to like the model and modeling programs all the way through into using the program. So to start off with, it's basically the 3D printing it's an automated process of building a three-dimensional object by adding material rather than subtracting it like traditional milling, which would be a big metal spinning like drill bit kind of thing that actually would cut out metal, right? That's yeah, that's where traditionally we've done a lot with manufacturing. Additive manufacturing is really cool because it's very much like being able to take it like a regular printer and lay it down in a layer and then add another layer and add another layer and keep building it up until you have a 3D object. And we do this mostly in plastic. There are a lot of different types of 3D printers, but the main one that came out that's kind of consumer ready and that is actually uh, most available is the FDM printing. That's fused deposition modeling, right? That came out from the RepRap open source project, and that's when all of a sudden 3D printing exploded. Before it was all pulled up in patents and everything else. And so that was in 2009 that it really, most people started exploring 3D printing, right? And 3D printing was kind of sold as this like magic bullet, like you can just anything and you press a button and it just comes out, right? And we got really quickly disillusioned to the realities of 3D printing because it is not as easy as pushing a button. One, modeling is a very complicated thing. That's for those of you guys in any type of mechanical engineering and you're needing to do modeling, obviously, you know that this is not that easy, right? It takes a lot. And so a lot of people who are like, well, what if I don't want something that, like, what if I want to create something? And that became challenging to learn modeling. So that's a whole nother skill in it up. And we're not going to really cover that. But the other part of it is that FDM printing, I would say, unlike some of the other more expensive printing options, has a much higher failure rate, both of machines and maintenance and the difficulties of diagnosing it. And I would say even the best people at FDM printing are getting probably roughly like 85% success rate, right, of your files. And now that may change if you've printed a file 100 times and you got it all the time. But sometimes the machine fails. Sometimes you didn't, something goes wrong and it fails, right? Comparatively, there are other printing methods that we actually have in our shop called like SLA, which is a stereolithography apparatus. That's a resin printing that you guys saw over there. And that actually, I would say we have a 98% success rate with models there, right? So it's just different process, although that resin is a lot more expensive. So
Is it because it doesn't have to depend on the whole extruder head and melting the filament and creating the layers? Why the SLA printer has a higher success rate?
yes and no. I mean, the question was for the recording here is that does it have to do with the actual printer head and the melting of plastic? It's just a different thing, and all of it it's not just that one thing, right? There's all of the different things like SLA, the machine, and it's working with a laser that's a lot higher resolution. The processes are a lot more mechanical. Where you're right. I mean, the actual taking basically filament plastic and melting it and extruding it, there are a lot of different layers to that, from being able to put it where you want it, to heat it the way you want it, to like, and there's all of these things like, well, do you do retraction after you layer a thing? Does it actually move up? Does it move down? There's just so many variables that affect how good it works. So it where the SLA has less variables that you need to worry about. And the software tends to be better, and it's a different process, right? So, but in general, FDM is great for cheap, easy, quick 3D prints and engineering proof of concept, right? Where SLA, it's a lot higher resolution. It'd be good if you need to eventually put it on a mill and actually mill it out to do a test fit, because you're going to have much better tolerances from the SLA. And then there's other things like SLS, which is a powdered version where I think it's something selective laser sintering is SLS, and that actually it's a powdered nylon that a laser comes in and fuses it, and then it keeps doing it that way. And that has some advantages also, that you don't need support and that it's a lot stronger, right? So they all have their advantages and disadvantages. This is cheap. Like a roll of filament is like $15, and you can print it easy. Like there's just so even you can even get cheap 3D printers and 3D printer kits at home for a couple $100. So it's within the range kind of now of so many more people doing it, but it's still not easy. And that's kind of where what we're going to do today is talk about some of those things. So one of the issues that we want to look at is kind of what are the modeling in the files. So most 3D printers use STL or OBJ files. That is the file type, just like a .txt file or a .jpg file. That is your file type. And that file is not what is actually modeled in. That's always exported to. So you're going to model in either a parametric modeling program or a direct modeling program. So Blender, for example, is a direct modeling program. And Rhino and some of the other ones, where parametric is much more engineering focused. That's SolidWorks, it's Onshape, it's Fusion 360, it's a lot of, and that has everything to do with using parameters like this is this long and this is this high. You can't just stretch. You can't say, if I want to make a table in a parametric modeling program and I want to make my table bigger, there is no scale button, because you have a whole bunch of things like the screws. If you just scale those screws, you might be scaling the screw to a thing that doesn't exist, right? So parametric modeling, if you want to make something bigger, you have to go make the height, the width, the length bigger, this part bigger, that part bigger. It takes a lot more to scale something. So it's a different modeling understanding of how you do that, where if you want to make a troll's head and something artistic, you're not going to do it in a parametric modeling program, right? So that's kind of where they go. And those are what you will export in once you have your model done to an STL or an OBJ. There's also Thingiverse.com, which is the most amazing place on the planet to get models that someone else has already designed, where we are getting our models today, right?
It's like GrabCAD.
It's like GrabCAD. Yeah, GrabCAD is another great resource to find models. So one of the things that we're going to talk a little bit about next is that once you have your 3D file, which is an STL, we're going to go into slicing programs. So the models need to be sliced into layers and then converted to G-code, which is a mathematical plotting language used by CNC tools to create movement pathways. For the one that we have, we highly recommend using although this link is out of date, FYI. It's actually on our, let's see, Cura software available at wiki.circuitlaunch.com. So now if you go to, let's see if I have it already up. Here it is. So if you go to our wiki, which is wiki.circuitlaunch.com, all of the things that we need for the 3D printer is going to be there. Under here are 3D printers. This is the slicing software, which is the Ultimaker Cura. And then I have specifically and just recently updated this as of July 19th, 2022, this profile. That is today? Yeah. And so this profile right here has been updated to work really, really well with our 3D printers. We were actually having an issue and it's been resolved because of this new profile. So this profile is going to give you all of the basic stuff you need to be able to set your model up without having to worry about all of these different settings. And so this is Ultimate your Cura. This is our actual slicing software that we're going to take a 3D model and slice it into layers and then send those layers into G-code to our 3D printer. Sir.
The file that you upload into it,
Mm-hmm.
is it a .stl or .obj, or is it a different, completely different format?
The one that I am using is the top and bottom donkey for our donkey car that we're creating, and that is an STL file. So that pops in right there. That is our model here. Okay. I already have the profile in here, but what we're gonna, to get your profile, you need to actually go into preferences. The Mac and PC version will be a little bit different. Once you're into preferences, you're going to click profiles. I know this is kind of small on the recording. Sorry for this, but it'll be under profiles. And then you import your profile. And then the most important part is that you then need to, let's see, brim. Let's see, I have a bunch of initial layer height and things. I think this was the last one that I have and then you need to click activate depending on which one you're actually using. Okay.
Depending on which file you're using?
Depending on which profile you are using. So the profile you're going to get from wiki.circuitlaunch.com, and that's how you're going to put it into Cura. And that is going to have a bunch of your settings over here all taken care of, which is so much easier than you trying to figure them out because there's tons of different layers, right?
And this profile, what's the format of that? Is it .scale?
I think it's a YAML file. I'm not sure.
Okay, I remember asking you about this while back. Okay.
Yeah. But so this profile has all of these, it's like a small database of all these settings, right? So let's talk about some of these settings. So once you get your file in, there's lots of things like you can do to scale it, you can rotate it, I need to move it over a little bit. Like you can rotate the model, you can move it around, you can mirror it, and then we can talk about support and places like that. The one thing that you'll notice if you are doing a lot of 3D printing from Thingiverse, some files come in gigantic or tiny. And the reason for that is that somebody did them in inches and you're in millimeters, or vice versa. Anyone know how many millimeters are in an inch off the top of your head?
Is it 25?
25.4. Exactly. Good. And so if you actually if it's super tiny, you can try timesing the scale by 25.4. Right? Because then that went from 1 millimeter as a unit to 1 inch as a unit, right? And that will often size it. If it comes gigantic, usually it's a scale factor of needing to be 0.1. And so it's 100 times or 10 times larger, depending on what file it is. And you need to bring it down. And so that scaling will be how you do it. Ours, luckily, comes out fine. That's exactly what we need, right? So let's look at, so all of your model, or all of your things here are your settings. And there are a ton of settings in here. The whole point of the profile is that you don't have to mess with most of these settings, right? And so let's go through the settings that you do want to play with and some that are important or not important. One is the quality. I don't touch the quality at all here. The only thing that I've done that has changed is the initial layer height from the stock needs to be as high as the rest of the layers, like the same thing. I should make that, or I should make it double. If I make it 0.3, it creates this weird thing where it's trying to squish it. So you guys don't need to worry about it because it's all in the profile.
So basically, they're talking about resolution.
Yeah, this is kind of resolution. Each layer is going to be 0.2 millimeters high, so about 200 micron layer height. You can change those, but it honestly, this is the spot to stick with at first. Quality is not done here. It's done in speed. There's walls, which I don't touch anything. Top and bottom, I don't really touch anything. There's top and bottom layer thickness. Again, I don't bother with any of that change. Infill. Now, this is an important part of what we need to do. So for this file, the infill density is at 50%. That's probably fine for our needs. Honestly, though, I might bring it up just to about 75% for ours because it needs a little bit stronger. That's going to take a lot longer and put more filament. The one important thing, though, is that you don't use more than about 80%, 90% at max, right?
What about 25%?
That's if you go lower, that's fine. You just realize, so the infill, what that is every model of this is hollow, and you are going to need to fill that hollow space with something. So this automatically does that. And you can have control over like the way the pattern, all sorts of things like that. But the percentage, it doesn't need to be that high. For most things, you could actually make it at less than 50%. In fact, I think I am going to stick with 50 at this point. I would say for most models though, because it doesn't need to be structurally sound, 25%, 10%, 8%, it's fine. Totally fine. Unless you're building like the axle that's going to have weight and need to be structurally sound, it doesn't need to be. And even then, that grid inside, it's a grid, it's boxes, it's triangles, that's strong. It's almost stronger than just pure solid plastic that comes down in layers, right? So the one thing that you do need to make sure is if you were to go above 90% infill, the problem with that is that this plastic, it oozes, right? It's a liquid. And, huh? It merges, it blends, it does that. But the biggest thing is the computer has a set amount of size that it thinks that the plastic is going to take up in volume, right? If you say 100%, it says, oh, I have to fill this 100% with the volume of this, right? If the computer is off by even a little bit about how much plastic is actually flowing, right? What ends up happening is that plastic goes in and then starts squeezing out any extra, right? And so every little spot, plastic is oozing out, and then it becomes higher than the computer thinks it is. And then what it starts doing is it bounces along because it's got more plastic than it thinks it should be there. And that keeps exponentially getting worse. Right? And so what's going to end up happening is eventually you're either going to wear down the tip of your needle and the hole of your needle. It'll actually become oblong because of the extra pressure that it's putting on it, or it'll just knock your print right off, or it will get caught on your print, knock the fan off, or break the head of the printer. So please don't go over 80% infill. There's almost no reason to. Even if you want it pretty solid, like 80%, fine. It'll be very, very solid, right?
You said that's 50%?
Yeah, we're going to do it at 50%. And then the rest of this I don't bother with, just the percentage of infill density. The speed, this is how fast it travels. And this is a good place to increase the quality of your print by decreasing the speed. The slower you go in general, the better the print will end up coming out.
Give it more time to cool.
It may give it more time to cool, but it also just, it tends to be more accurate as to its laying down. It's going to have less flashing. It's going to have less surface changes. It's going to lay down a much cleaner line because it's there. So you can go up to about 60, which is fine. And you can go down to as low as about 25. But I find that about 45 is a good, it's a good combination of good printing speed and there. We were having some issues with the initial layer speed. I was actually having it was all the way down to like 20. And in fact, I was getting so much warping along with other reasons. So I brought up the speed a little bit, and it caused a lot better adhesion on there. So, but I'm still doing the initial layers 35 rather than 22. So in general, you don't need to play, again, for your first bunch of prints, don't play with this. As you get better, you can come in and play with all these things. The travel, I don't bother with. The cooling, I don't tend to bother with. The support, this is an important part that you will back and forth. For our model here, you don't need support. However, there are two places that or two ways that you're going to add support. Support is basically the material that it creates to hold something up, right? So that it doesn't just fall over. Yep, like a vertical piece doesn't need that because it's there. Anything over about 45% should use support. This is not over that 45%, so I can be able to probably print this without any support, right? But that's fine. Some of these you are going to need support. If you choose support, you'll use either touching the build plate or everywhere, right? Then if it's touching the build plate, the only place it's going to put support is where there would be support that would touch the build plate, right? Over here on, like, for example, there's a little overhang here. If this overhang were bigger, there's a couple of these here, right? And I did support touching build plate, it wouldn't create support there. However, if you do if you click everywhere for support, this is too small, it probably is not going to add that, but if I did have an overhang here that wasn't necessarily that support wouldn't have touched the build plate, it just creates support on your actual thing. So if you imagine, like, for example, a big C like this, right? The support would be built on the top of your model to the other part of your model that needed support. If you do touching build plate only, it won't support those. So those are the two different methodologies of support that you're going to choose. It's everywhere and touching build plate. Okay? And in general, if the angle is less than 45 degrees, it's like flat or something like a very steep overhang like that, you need support. If it's kind of at 45 degrees or a much steeper angle, then you usually don't need support. And a lot of that's just going to be trial and error, how you figure that out. So I'm going to turn off support for our model here. Build plate adhesion. This is another important part here. So the build plate adhesion, we have, I have a choice of skirt, brim, raft, or none. If my part, like for example, our parts that we have on here, they're flat. What they will do is oftentimes they start peeling up at the corner, and that can cause a problem. This one probably doesn't need a lot of build plate adhesion, but it also doesn't have a lot of surface there that needs to there, where every time it prints on here, it's going to make it move a little bit and could knock it off. So in general, I like brims for a lot of things. The brim, and in fact, I just updated this profile specifically so that it will work better with the brim in this thing. The standard profile that Cura does, the brims are bad. They've been curling and not actually helping. But a brim is just a little skirt. Let me see, for those of you guys. Yeah, hopefully you guys can see on my little profile here on my screen, this is just this little plastic stuff that goes around your part, and it comes off really super easy. But that brim, what it does is it's kind of like a Band-Aid almost, or like an adhesive layer. It just sticks down to there, and it helps it from peeling up, which is really nice. So I highly suggest using brims if you have adhesion problems. For our printers, they're on glass beds. You'll use a little bit of this purple school water soluble glue. It's like a glue stick. Yep. And that's easy for adhesion on that. The other ones that you're choosing, there's skirt, which a skirt, it doesn't, I don't understand the skirt. It's more like a line around it. It's just literally a line around your part. That's all it is. So I don't know why they call it a skirt. I don't even know why you'd use that. Maybe it's just to clear the needle out before you put it there. Maybe it's so that you can level the printer. I'm not sure. Then there's Raft. Raft is a very highly expensively resource dependent part. It will add sometimes an hour or more to your print. It will often be difficult to separate if you're using Raft. And it, in my opinion, is a waste of time, and most prints don't need rafts. The times that they do need rafts is when you have a very tall, long piece of something that doesn't have a flat, even have a flat ending, and so you're going to be printing it, and it's going to be supported fully by its own support, right? In that case, a raft is really good because then it widens up the surface area that supports your part. And there, so for us, you know, our robot Ricci's arms, these long arms that don't have any type of flat support, those were all printed on a raft vertically and needed to do that way, right? So, and then there's a couple other things here like brim line count, brim width, brim. You can play with those if you want, but as I said, I've got these set now to be pretty good. That's all the settings that you need to worry about in here, okay? Now you simply click slice, and it's going to slice your model up, and then you save that as G-code. And so that's 12 hours and 38 minutes at 50%. I think I did mine at 70%, and there was like another 2 hours of printing for the models that we've already done. So you can see it takes a while. You can change that dramatically by lowering the infill as well. So then I save to disk.
And does the SD card print?
No, I save it to my computer, right? Okay, and then we're going to start there. I'm going to pause our print here and get set up, and we're going to actually go over to our printer and do some there. So let's pause here. Printing here. There we go. Okay, connect. Let's see if I actually can connect to this actual printer. Okay, so we have a printer here. Now, the first question you guys are going to have, obviously, is where. Make sure I'm actually recording here. I don't see my screen, or my face, but that's okay. So all of the printers have a web interface, right? So the web interface is, and the way you get to the web interface is we have, for the education ones, there's actually a page in there that says 3D printers, and that has all of the addresses to these printers, right? Our two circuit launch printers, they actually have them written right on there. And there's two addresses. There's the name address, which is like on the top here, the series 1-10675.local:5000. And then there's an IP address. If you're a Mac, you can use the name server. If you're a PC, you have to use the IP address because for some reason, PCs can't do that. I don't know why. I'm not sure what the reason is, but both of those, that's part of our thing. So,
Like the connector all the way from San Francisco.
no, you have to be on the local network here to be actually to connect. Yeah. So, although in our program, if we do have a computer, if you left your Raspberry Pi on, right, and you had a desktop version, then you could connect to there. So, so what we're going to do is just to start off by a couple different things. Once you connect to the actual 3D printer, there's a couple different tabs. There's the control tab, the temperature tab, and the files tab. The control tab, if I've connected, hopefully I'm connected here. Let's see. It looks like I have a little bit of issues with this particular printer. We were having some.
So you got to this web page through Circuit Launch Wiki?
Nope, just through the main drive. So I'm having troubles with this printer, which is why I actually connected to it. But what I need to do is I need to change the filament on 10672. So I'm actually going to do that. Series 10672. And we're going to go to this printer over here.
So that's what you have to type it up.
Yep, in your web browser is how you're going to access this. Okay. And so once you actually connect to the 106.7.2, you can go to the control, and for example, I can lower the bed, I can move the head, all of that right there. And what you'll want to do your first time is probably, oops, you'll probably want to home the platform, home the head, right there. That'll be the first step that we want to do. So now I need to change the filament on this one because the filament is out of, it's almost done, so we're going to need to change the filament. I'm going to lower the head so it's a little bit there. I'm probably going to pull. You just don't click it that as many times as you don't want to. Yeah. Yep. And then how much you move is actually listed, I think, in here. So I think it's a 5 mil, but that's the extrude. The motors are at, I think 10 steps. I think they're not actually millimeters, but I'm not sure. Yep. Then the next thing that we want to do is actually heat up the filament so that we can there. So on here, we're going to put in 210 and hit enter. Sometimes it goes back to off. That's okay. That's the way. It just goes back into the 10. Yep, this is the Mac, and the PC will be the same because it's your web browser.
Is it the max heat, like 210?
No, so the heating that you're going to be doing, you actually need, over on those printers, it says 210 is the recommended amount. 205 is kind of the lowest amount, and 230 is the max amount. You technically could make it go hotter. Please don't, for any reason. Some people think that if you are actually trying to, if you're actually trying to get it unclogged or something, that you should heat it up a lot, and that's bad because it'll actually carbonize inside the tip, and it'll create this like burned little piece, kind of like charcoal on the grill, right? And that will cause a clog and can permanently damage the needle. So please keep it within those temperature settings. And Cura, as it goes, it actually, the first initial layer, it ends up saying, if you don't put a profile in, it'll say do it at 200, which is actually too low, and you end up clogging and having adhesion problems. So, so now that my printer, I can see that on my actual screen, it's about 217, 218. It overshot a little bit. It'll come back down. And so what I'm going to do is I'm going to just simply grab right here, pull up this little tube, and this is the filament. And to remove your filament, there's actually a button right on the side, right here. It's a release. That's that guy right there. Yep. And you can use that. I have one hand here, so I'm just going to pull. It's heated. It pulled out. And so that's how I'm going to remove the filament on there. And so then you can just simply take your actual filament and pull it out. You want to hold on to that. The one thing that you want to make sure is that this end right here, this, you have to put it through the hole. Would you go ahead and put that right through the hole? Like wrap it around. Yep. Well, I mean, you can do it that way too. It doesn't matter. Or go all the way around again and do the hole just to tighten it up. But the thing that you don't want, that probably is too, you should be able to get it through there now.
This one?
Yeah, put it in the first one and then put it through the second one, like kind of loop like a thread. Yep. And the reason we're going to do that is because if you leave this, yeah, like if you leave it, it just coils under, it creates knots. And the problem is that knot won't actually show up until about an hour into your print because it's just looping under a little bit. So that's really important that when you take a piece of filament off, or we take the filament off, that you do this part right here. Now, for our printers here, any filaments that don't have names on them, you're welcome to use. If they have a name on them, those are a member's filament, so please don't use those. So.
Are the names like they have like a tag on it?
No, just like, for example, I don't see any names, but if you had another printer right here, like this one doesn't have a name written on it anywhere, again, you could, but usually people just like, they type, they'll, in pen or something, they'll write their name on it. So, so that's the rules for the filament. Now that I've got my printer, it's all heated up, it's ready to go. Let's go ahead and take our new filament. I need a cameraman to help me with my one-take video safety. Would you help me here for a second? Sweet. So what we're going to do, I'm going to take my new filament right here. I'm probably going to grab some snippers right here and just cut off this like weird mangled part right there. I'm going to take my filament and I'm going to first put it into the tube and put it on there, and then I'm going to just feed it through until it comes out my tube. Okay, and now to set this up, what I have is that little button that we showed earlier. That's going to be important. There's a little hole in there, which is the top of the needle, and it's something that you're probably not even going to be able to see even if you look closely. But the idea is I want to try and get this as straight as possible. I'm going to put this in down past that hole. Sometimes it may get stuck and you kind of have to move it around or twist it, but now I can feel it actually going all the way there. And then if this is hot, I can then just literally give this a bit of push and see how it squirts out. That's good. And it squirts out nice and clean, and that's hot, by the way. But that's the filament that comes out, and there's some old stuff. Now it is loaded and ready, and that is good. Now I did move this a little bit, so I should home that again one more time before I start my print. So the next step that we're going to do is actually load up our file onto our printer. So so on the actual printer, we're going to take our files and simply click upload, and then you're going to upload the file that we just made from your G code. That one is right here. I have my top and bottom donkey, and I did use I labeled experimental, but that's just because I was playing around with it. But that's the file that we want. Once it's loaded up, if you can't find your file, click upload date, because that'll put it at the top. And then once you're there, you are ready to actually click print, and that actually is the one that is right here. So like I said, before I go too far on that, I did want to just home both of these real quick. And then I can click print, either from the list down there or from here. Nope, not. I mean, this clean, as long as there's not filament on there, you're probably okay. If you actually need to clean because there's too much glue, then you can just take a little bit of water and a paper towel and the scraper. Now we have our 3D printer tools, which is our blue bin right here, should have a lot of the printer tools that we need. You know, there's usually some different things in here that will be needed. The main one is your scraper right there, and some of the things if you needed to actually repair it. There's some school glue stuff on there. Again, here we're going to take a little bit of the glue stick, and just simply go over where your print is, right, like that, and that'll be enough. Around the corners, and we're set with that. So doesn't have to be an amazing job. And then now once the printer starts, this is going to be the leveling procedure. Most of the time the leveling is going to be pretty good and you're not going to need to do anything. This first line is just a clearing line. So you don't need to worry about the level at this point. There are 4 screws on the underside of this thing, the little black-headed screws, and right in the 4 corners of the actual bed. Yep. And so once it starts, what I'm looking for is a flat bead. Now, this is a really good example of a flat bead right here that's set. If I touch it and across, it feels flat. What I want to try to avoid is it feeling like either a garden hose on a table, which would not be a flat bead, or if it's too high, or like the bed is too high, the bead is going to come out a little bit loose. Like you can actually see there's a little spot right here, but I think that's mainly because there was glue too high, that it didn't come out quite as well. In general, if it's a nice flat bead and it skips a space, the bed is too high and it's causing it to not come out. So right now I've got a really nice level bed and it's printing. I don't think I'm going to need to do anything to this particular print. We should be okay, and we're set. But that leveling is really important to understand, and it's going to be something that's hard to see in a video. You'll actually want to, at some point, intentionally make the bed go a little too far and intentionally make it go a little bit too close to see the difference of that, okay? There is also a file on these printers called bed level, which is just basically a bunch of squares. And so you can actually do it and it'll print that. So now the main goal with these is that I want to be here for my first layer, right? I want to be here, like stay and babysit your first layer, especially if you've never done it for a while, right? Once the first layer is completely done and well adhered, you're more likely to have a good print, and then you can walk away with your printer, right? If you don't babysit your first print, at some point it comes off. It could come and have a big like glub of like plastic fused to the head if it pops up. But so if you have a successful first layer, then you'll end up having a much more likely to be successful layers all the way through there. So the only other thing that we want to talk about is the removal of the actual prints.
Use the one with the flat end and the other rounded as a hammer. And then what you do is you slide it under here and just tap it. Tap, 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 tap. Keep tapping around until you get it completely done. That's the most important way to, most important part of taking off models is using these two tools to do it. Don't just pry it off because you can break the bed. Okay, thanks.